NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve equations involving the floor function using a clean graphical method, and then confirm with algebra. We'll tackle two examples. First, floor of x equals 2, and second, floor of x squared equals a, where a is a positive integer. Example: we want to solve floor of x equals 2. We'll draw two graphs. 1, y equals floor of x, the classic step function, and 2, the horizontal line y equals 2. Then we'll highlight where they overlap on the x-axis. Now, let's highlight the intersection. The step of the floor function at height 2 runs from x equals 2 inclusive to x equals 3 exclusive. So the solution set is the interval left bracket 2, 3 right parenthesis. We can also confirm this algebraically. By definition, floor of x equals 2 if, and only if 2 is less than or equal to x, and x is strictly less than 3. Example: next, solve floor of x squared equals a, where is a positive integer. We'll first build intuition with a graph of y equals floor of x squared, then derive the algebraic intervals. Let's draw a new coordinate system. We'll sketch the parabola y equals x squared in a soft color, and then draw the step function y equals floor of x squared as horizontal pieces at each integer y level. Finally, we'll place a horizontal line, y equals a to c, where it intersects. From the definition of the floor function, floor of x squared equals a if and only if it is less than or equal to x squared, and x squared is strictly less than a plus 1. Taking square roots gives square root of it is less than or equal to the absolute value of x, and absolute value of x is strictly less than square root of a plus 1. That splits into two x intervals. On the right side, from square root of an inclusive to square root of a plus 1 exclusive, and on the left side, from negative square root of a plus 1 exclusive to negative square root of an inclusive. That is our complete solution. The solution set is the union of these two intervals. To visualize, at y equals a, the floor graph touches in two horizontal pieces, one on the right between square root of a and square root of a plus 1, and a mirror piece on the left. These project down to the two x intervals we just wrote. Recap: for floor of x equals 2, we intersected the line y equals 2 with the step graph and read the x interval left bracket 2, 3 right parenthesis. For floor of x squared equals a, we used the definition of the floor function to get a less than or equal to x squared and x squared less than a plus 1. Then took square roots and split absolute value to get the two intervals. Great work! Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.